The Fukushima Daiichi nuclear disaster, one of the most significant nuclear accidents since Chernobyl, occurred on March 11, 2011. This catastrophic event was triggered by a massive earthquake and subsequent tsunami off the coast of Japan, resulting in severe consequences for the environment, public health, and the nuclear industry. Background: the Fukushima Daiichi nuclear power plant, operated by the Tokyo Electric Power Company, TEPCO, is situated in Okuma, Fukushima Prefecture. The plant comprised 6 boiling water reactors, BWRs. At the time of the disaster, 3 reactors, Units 1, 2, and 3, were operational, while Units 4, 5, and 6 were in maintenance shutdown. Causes of the disaster. The disaster was initiated by a natural event and exacerbated by several factors: earthquake and tsunami. A 9.0 magnitude earthquake struck off Japan's coast on March 11, 2011, generating a tsunami that overwhelmed the plant's defenses. Flooding of cooling systems. Tsunami waves exceeding 14 meters breached the plant's seawall, flooding emergency diesel generators in the basements, which were critical for cooling the reactors. Loss of power. The flooding led to a station blackout, cutting off AC power needed to operate cooling systems, resulting in reactor core overheating. Course of the disaster: core meltdowns. Without cooling, reactor cores in Units 1, 2, and 3 overheated and melted down, releasing radioactive materials. Hydrogen explosions. Hydrogen gas buildup led to explosions in Units 1, 3, and 4, causing further damage and releasing more radioactivity. Radioactive release. Significant radioactive isotopes, including iodine-131, cesium-137, and strontium-90, were released into the atmosphere and ocean. Immediate response evacuation. Approximately 160,000 residents were evacuated within a 20-kilometer radius, later expanded due to contamination spread. Cooling efforts. TEPCO and emergency responders used seawater and boric acid to stabilize the reactors, though significant radioactivity had already been released. Containment and monitoring. Extensive radiation monitoring of air, soil, food, and water was initiated by Japanese authorities and international agencies. Human health. Acute radiation exposure was limited, but long-term effects are still being studied. An increase in thyroid cancer among children has been reported, though a direct link to the disaster is debated. Long-term effects: decommissioning efforts. Decommissioning Fukushima Daiichi is ongoing, expected to take 30-40 years. This includes removing melted fuel, dismantling reactor structures, and managing radioactive waste. Radiation monitoring. Continuous environmental radiation monitoring is essential for public safety. Decontamination efforts are ongoing, but some areas remain uninhabitable. Public perception and policy. Public distrust in nuclear energy has grown, leading to increased investment in renewable energy sources and enhanced disaster preparedness. Lessons learned: improved safety measures. The disaster underscored the need for robust safety systems, including better defenses against natural disasters, backup power supplies, and emergency cooling systems. Crisis management. Effective crisis management and communication are crucial in mitigating nuclear accident impacts. Transparency and timely information dissemination are key. International cooperation. Global cooperation was vital in addressing the Fukushima disaster. Sharing knowledge and resources enhances nuclear safety worldwide. Conclusion. The Fukushima Daiichi nuclear disaster remains a stark reminder of nuclear energy's potential risks, especially in natural disasters. It highlights the necessity for stringent safety standards, comprehensive emergency preparedness, and continuous evaluation and improvement of nuclear technologies to prevent future catastrophes.